So good afternoon everyone. So my name is Edwin and thank you for joining me at my session, Augmented Reality powered by ColdFusion and React Native. So the main takeaway I want from this session is just an introduction to Augmented Reality. It's not something complicated, it's very simple if you understand how it works, and I encourage you all to try it once you've left this session. So before we start, I'll just give a quick introduction about myself. So I've been working as part of the Adobe ColdFusion engineering team for the last 3 years now. Some of the areas I've been working on are WebSockets, security, SAML integration, ColdFusion administrator, and the performance monitoring toolset. In my spare time, I'm an Android enthusiast, and I also play a lot of video games. And my initial line of introduction was going to be, if you have any of these doubts, you can come find me at the booth. But I lost my baggage in transit, so I'm probably going to head out and buy a few clothes right now. So you can find me at my email, samanjo@adobe.com. If you have any queries, you can just mail me and I'll get back to you as soon as possible. So this is briefly going to be the agenda for us today. So I'm going to be introducing augmented reality to you guys, since not all of us will be familiar with it right off the bat. I'm going to bring about some popular use cases of it from the recent past. I'm also going to give a small introduction to React Native, since it's not a very common framework which everyone uses. Then we're going to start building a treasure hunt application using augmented reality. We're going to be talking about two types of scenes in them. One is location-based scene, which get activated when you reach a particular location, and the other is marker-based scenes, which get activated on recognition of some kind of image markers. And finally, I'm going to be talking about some additional features of augmented reality as well, which are not pertinent to our treasure hunt application, but you might find them useful in the application that you might want to build. So the main question, what is augmented reality? It's essentially just adding some sort of digital components into the real world. It's oftentimes misconstrued with virtual reality, where we immerse ourselves into a virtual world. So since we need to add some sort of images or objects into a real world, we need two engines for doing that. One is a tracking engine and the other is a rendering engine. So the tracking engine basically uses a set of sensors to map the real world. And the rendering engine just puts those objects or images onto that mapped boards. So some of the sensors which you'll be using are your camera, your gyroscope to determine which direction you're facing, an accelerometer to find out how fast you're actually moving, etc. And the rendering engine can be a smartphone display, it can be an augmented reality or a virtual reality headset, etc. So nowadays, these tracking engines are actually built into our smartphones, since our smartphones actually have all the sensors which you already see on the screen. So smartphones are actually the perfect vehicles for running augmented reality application. And the application you're going to see today is going to be actually displayed on a smartphone. So the reason why augmented reality wasn't popular until now, it did spike around 10 years back, but at that time the hardware and software was not really developed. There were too many components involved, like the sensors you saw earlier. Earlier you needed to attach all the sensors yourself. You needed to get all the information from those sensors, and you needed to map them according to the timestamp. And sometimes those sensors could fail you, they might not send information at times, and so for that reason, debugging the code was such a big headache. Nowadays, we have more advanced hardware and advanced software, so we don't have to worry about collation of this data as such. All we need to do is actually build our applications. And some of the popular SDKs which are used for building augmented reality applications are Oculus and Google's Daydream project. Today I'm going to be focusing on a library known as meteoric. It's a React Native library, and we'll talk about its capabilities in just a while. So some popular use cases of augmented reality are, I'm pretty sure all of you will be familiar with the first one, Pokemon Go. If you actually break down the architecture of Pokemon Go, it only uses augmented reality in about 5% of the application. The remaining 95% of the application is basically an interaction with Google Maps API and building your own Pokemon gyms and collecting Pokemons, etc. So Pokemon Go is actually a perfect illustration of how a very simple idea paired with the right execution can give you great results. They made $2.4 billion in just their first year. The second is Spider-Man Far From Home. I'm pretty sure a few of you will have seen it. So if you've not seen it, this is Jake Gyllenhaal, and he plays the role of villain, actually acts as a hero called Mysterio. And if you see he's actually emitting some sort of magical stuff, but all that is not real. He uses augmented reality to actually convince people that he's a super villain. And the third is the furniture apps. I'm sure all of you are familiar with this. Even IKEA uses such an application. So nowadays, you don't actually have to visit the furniture store to buy your furniture. You just need to download the app which they provide. They provide you with a catalog of all the different furniture items available in the store. So you can just select the item, point it at the location you want to drop it in, and it will show you whether the colors actually match the ambience of your room, whether the size restrictions actually permit you to buy this, etc. So before we actually get started on the present application, I want to know how many of you have actually used React Native before? Oh, okay. And how many of you have used React at least? Okay. So for those of you who are not familiar, I'll just give you a very quick introduction to React and React Native. So React was developed by Facebook a couple of years ago, the target being to make single-page applications. So the main structure of React is that it has a number of components with parent-child relationships, and these components have something known as the render function, which separates it from other modern UI frameworks. So this render function actually returns HTML. So React is one of those few frameworks where there's no separate HTML and JavaScript. Your HTML is going to be written within the JavaScript, and you can actually assign HTML tags to JavaScript variables and use conditional logic to rendering those. So the render function returns your HTML. So how do you actually redraw the HTML whenever your variables change? That is going to be mapped using something known as state variables. So whenever you do any change in your state variables, the render function is automatically going to redraw the entire UI. Not the entire UI, wherever the variables are being referenced, it's going to redraw those places. So React Native is just an extension of React. It's exactly the same syntax. One big change is that it supports cross-platform capabilities. So you don't need to build a separate code base for iOS and a separate code base for Android. You just need to write one code base, and React Native will take care of giving you both applications. And also React Native replaces some HTML components with its own components, just to provide this cross-platform capability. So I'm going to show you a quick illustration of what it would look like for regular JavaScript compared to React and React Native. So in ordinary HTML and vanilla JS, this is how you would write a simple login form. So in this case, I'm just accepting a user input as the username, and I have a button. And on clicking the button, I'm going to make a call to a function called login user, which is in turn going to contact my server. So as you can see within the div, I just have an input type equal to text username, and then the button, I have an on-click function, and I'm calling the login user function. So the same code, if I'm going to be writing it in React, is going to look like this. So remember we talked about components. So I have a login component over here. Then we talked about the render function. So the render function is going to return the actual HTML which you want to be displayed on the screen. And finally I have another function called login user which is going to contact the server. And within the render function, if you see, it's returning HTML. And within the input, you can see that I'm referencing a state variable called this.state.username. So if you click on the input and if you start typing a username, it automatically gets tied to the state variable. And anywhere you reference this.state.username in your JavaScript code, it will have the latest value of this username. So in React Native, it's exactly the same syntax, just that again cross-platform capabilities, but you'll be noticing a few slight differences. The first difference is that div was replaced by something known as view. So this is just to provide the cross-platform capabilities, it's nothing too drastic. Within a div, if you had multiple elements, those elements would be aligned one next to each other. Whereas in a view, if you have multiple elements, those elements will be rendered one below the other. So again, input is replaced by something known as text input. So text input, in this case, is again the equivalent of an input type equal to text. So you have same inputs for passwords, etc. Whereas the on-click handler, it's exactly the same way. So that is just a quick introduction to React Native. So I hope that everyone understood that, so that you don't get alienated when you come to the code part of the augmented reality application which you're going to build. So for this treasure hunt application, it's very simple. The architecture of it is going to be with ColdFusion at the backend. I've created some REST APIs to serve the functionality which I need for the actual augmented reality application. We're going to write that in React Native. And for development, you would actually need a Node server for hot reloading. but that would not be needed for when you're using it in production use. So React Native is going to spit out an APK file for Android devices and an IPA file for iOS devices. And these devices are going to be contacting ColdFusion using REST APIs. So what exactly is the ColdFusion backend actually going to do for us today? So the first is to maintain the state of the user. We just have a simple login logout functionality on the app. So once the user logs in, we check whether the login credentials are present on the backend. Secondly, if you want to create a very dynamic application, you don't want the clues to be the same always. You want to keep regularly changing your clues. So for that capability, I've added the clues to the ColdFusion REST service. Finally, the resources which we are going to be using in our augmented reality application, they can be quite heavy. For example, if you're using 360 images, which are in either 4K or 8K resolution, they'll easily cross over 4 or 5 MB. And even 3D models which you're going to be using, the very smaller ones start from 600 to 700 kilobytes. So we don't want to store all this on the app itself. We want to store it in the ColdFusion backend and receive it as we start finding our clues. Finally, we're going to be caching the positions of these objects in the real world. So whenever we embed an augmented reality object in our application, it needs to be attached to a position. So these positions would change depending upon the form factors of the device you're using. So for that, I'm going to be using ColdFusion's caching feature. And finally, if it's a location-based scene, I'm going to be validating the parameters of the location. So for that, I have another function. So let's just quickly take a look at what the ColdFusion code would look like. Right, so this is a very simple CFC which I have written for REST services. So to create a REST service, just set REST equal to 2 and give it a path, and then it would be accessible on a URL like this. So the first function I have is the login function. In the login function, I'm taking two arguments. One is the username and the other one is the password. And then I'm actually validating whether my username and password exist in my database. So as you can see, I'm doing a simple CF query. Select star from users where username equal to given username and password equal to given password. I'm using CF query param because I don't want to expose my ColdFusion backend to SQL injection attacks. And finally, if a user exists with the given username and password, then it will return at least one record. So in that case, I'm returning true, otherwise I'm returning false. So the second functionality of this ColdFusion backend is actually to just get the clues which we have for the treasure hunt application. So this is a simple get clue function and returns the clue based on a clue ID. So I'm getting that as a query parameter as well. Similar CF query over here, nothing too complicated. Yeah, I'm getting a clue from the database AR, and yes, pretty much the same thing. So coming to the caching part. So before I actually return this clue to the augmented reality application, I'm going to transform it and cache it. So like I said, we need to support multiple devices with different aspect ratios. So the devices which we have bought earlier to 2017 more or less have an aspect ratio of 4:3. Whereas the ones which we are buying in 2018 and 2019, they usually have an aspect ratio of close to 1. So something which, if you give a position to a particular object in your augmented reality application in a 4:3 aspect ratio device, it might not necessarily come into frame in a close to 1 aspect ratio device. So that is the reason I created this function. So this function just calculates the new position. Initially, it checks it whether it's present in the cache. If it's present in the cache, it returns it right from the cache. If it's not present in the cache, it goes and finds the new position based on the form factor, just multiplies it with that. Then it dumps it in the cache, and then finally it returns it to the augmented reality application. The final function is just a verify location function, just to check whether the user is in the radius of a particular location in case of a location-based scene. So you'll understand that much better when we come to the React Native code. So before we start building the augmented reality side of it, we need to understand a few concepts about augmented reality. So the first thing is known as the scene. So the scene basically acts as a container for all the augmented reality objects which you're going to be using in your application. So it's not necessary that you need to have only one scene in your application. You can have multiple scenes, and these scenes basically act as a 3D equivalent of your HTML page or of your so in your div, when you have multiple elements, like I said, you will put them side by side. In a view, you will put them one below the other. Whereas in a scene, they have objects embedded in 3D space. So basically, you would use a 3D graph system. So in a 2D graph system, you have only x and y coordinates. In this, you just follow the left-hand rule. You have your x, y, and your z coordinates. So this is a very simple scene which I've shown a screenshot of. It contains some sort of a grassy terrain. So that's the first component of the scene. Then there's a baby dragon which is lying on the grassy terrain. So that is the second component of the scene. And finally, there are a couple of rocks which are on the grassy terrain. So that's the third component. So scenes can contain any number of augmented reality objects, but you would ideally want to minimize the number of components in your scenes, because see, the more number of components you have within each scene, the more memory intensive your application tends to become. Also, in React Native, we are going to be using a library known as meteoric, and meteoric supports some operations on these scenes. So you can see them mentioned below. There's on tracking, on pinch, on rotate. Here are a list of other ones: on hover, on flick, etc. So the most important one is on tracking updated. So this is how you would create a very simple scene with meteoric. So all you need to do is open the Vero AR scene and close the Vero AR scene, and that will initiate your augmented reality experience. Although in this particular scene, we have not put any elements within our scene, so it will just initiate and go into it. You can see I have overridden the on tracking updated and attached a callback handler to that, and that is because, as we mentioned in the earlier slides, tracking engines take time to actually start. Even in the most sophisticated of smartphones, it takes around half a second to 1 second just to initialize all the sensors and map all the data to the exact timestamps. So if you start embedding your objects, the augmented reality objects, into your scene before the tracking is already initialized, then they're going to be appearing at random positions. And once tracking is initialized, they're going to snap to a different position. So to avoid that, you usually override this on tracking updated function. So I'm just going to show you a quick demo of what I've built using augmented reality. So the first page is a very simple login page. So this is going to contact the ColdFusion server to check whether the user credentials are there. And before we continue, I'm actually going to explain to you what I've built over here. So I've built a marker-based augmented reality application. So marker is basically some sort of a visual clue which the tracking engine will try to identify. And when it identifies those markers, it's going to try to place some augmented reality objects on those markers. So for the purposes of this demo, I've used some markers with triangular shapes on them, and all of them are different. On the top right hand, you can see a counter. That counter is basically just a count for the number of clues you found in the treasure. And when you hit 5, it's going to say congratulations, you found all the clues in your treasure. So those are the different markers which you see. So on hovering over the first marker, you see that there's an image of the CPU, so nothing fancy over there. Immediately, as soon as the marker is being able to scan by the tracking engine, it will be attaching your objects to the marker. So the second one you saw over there is an example of an object which has a physical mass attached to it. So let's say that in your augmented reality application, you have two balls which are going to collide with each other. If you don't provide any mass to those balls, they're just going to go right through each other as if they don't know each other exist. So if you provide a mass to them, if they're of the same weight, then they're going to go equally apart, or if one is more heavier than the other, then it's going to move less further, or one is lighter, it will move more further. So you can attach even physics-based components to your virtual augmented reality application. So this is the third clue, is just a picture of a fox with something known as a particle emitter. The fourth is Pikachu, and I've actually made the Pokemon theme song come on when it finds Pikachu. So I don't think you can hear that. And the fifth is something known as an orbital camera. We'll cover that later on in the demo. And on finding the fifth clue, it basically says, congratulations, you found all the clues. So let's first take a look at location-based scene before we move into marker-based scene. So in location-based scenes, the idea is pretty simple. You give the user a particular location he needs to go to, and once he goes to that particular location, the scene gets activated. It's something like how you have in Google Maps in your augmented reality view. Let's say that you're traveling to Vegas, and once you reach Vegas, you want to say welcome to Fabulous Las Vegas. So you can do something like that using this location-based scene. So before enabling the location-based capabilities, we first need to understand how to embed objects into a scene. So we've initialized the scene now, we'll start looking at how we can embed these objects. So these are just a bunch of different objects which I've shown. There are a lot more if you go to the documentation site of React. So for images, you can choose static images using the image tag. You can use animated images, you can use 360 images. For 3D models, you can use object tag or you can use 3D object tag. Then box is for a very simple box, and then you can use text input as well. There are a bunch of different tags for displaying video, and there are a bunch of different tags for displaying audio based on the type of audio requirement. That will also be explained later on in the presentation. So now that we know the different types of objects which you can embed in your scene, this is how you would actually embed it. So as you can see on the code on the right hand side, within my scene I have two very simple components. One is an image of some confetti which is falling from above, saying, if you reach the end of your present application, just to congratulate you. And the other is a text saying, congratulations. So if you see the source for the particular image, it says URI HTTP localhost 800 confetti virtual. So this is fetching it from a remote resource. You can also pack it into the application and you can call it using your JavaScript's require functionality. And if you're fetching it from a remote place, then it's most probably going to take a small bit of time just to fetch the resource. So in that case, you might want to use a placeholder, something like a loading GIF or a spinning wheel. So each 3D object which you put within the augmented reality scene needs to have a position attached to it. So that position will be in terms of an X, Y, and Z coordinates. If you don't specify any position, it's going to be placed at 0, 0, 0. And basically, I had a problem when I was setting up my applications and I didn't know about this. So every time I put an object within the scene, I wouldn't be able to see it because the camera and the object would overlap. So you need to take a step back to actually see the objects in the augmented reality application. Moreover, you can attach some styles to the objects in your application. Firstly, is dimensions. You can give a position for it. You can give a height. You can give a width. Sometimes you don't want your aspect ratio to be 1:1. You might want it to have it distorted in some way. In that case, you can use dimensions. You can use transforms. You can actually rotate your objects along X, Y, or Z axis. Then you can also make it draggable so that you can drag it with respect to the real world. And also, like we saw in the demo, you can attach physics to it. You can specify mass and other properties for it. So now that we understand how we can embed our objects, all we need to do is actually attach location monitoring to our application. So I'm going to be using React Native's geolocation API. It's very simple. So it just takes a couple of properties. The first property is whether you want to enable high accuracy or not. Second is the timeout, and third is the maximum age. The maximum age basically tells React Native how often you want to fetch the location. So either you can get the position only once, or you can keep continuously monitoring the position based on your needs. Also, this permission needs to be enabled separately in both Android and iOS manifest files. It's not enough if you just write the location code within React Native. You actually need to go into the separate manifest files and edit them to give these permissions. So let's take a look at how our location code actually looks like. So this is a simple location component I've written over here. Within the constructor, I'm just initializing the state variables which are going to be used within the augmented reality application. So I have two flags. One is if tracking is actually initialized within my application, and the second flag is whether I'm actually going to display the particular scene or not. So that will be when the user actually reaches the final destination. Also, I have latitude and longitude initialized over here. So the render function is going to return some sort of HTML over here. So as you can see, I have a below AR scene. This is actually going to initialize my scene. And over here, I initialized a camera. And apart from the camera, I have another image over here. So this is a reference to a JavaScript variable. So this is something you can do unique in React.js and React Native. You can add HTML elements and assign them to JavaScript variables, and then reference those variables within the HTML code itself. So over here, I have an animated image with a confetti GIF. So component did mount is a React lifecycle method. So this would be called once your component is actually initialized. So the first thing which I'm going to do is make a call to the ColdFusion REST service. I'm using a library known as Axios for that. So once I get a response from that based on the latitude and the longitude, I'm going to set that in the state variable. So any place where within the render function which uses the state variable is going to get updated. Since we're not using it, the render function will not actually be invoked again. So finally, we're going to use the location API. We're adding a watch on that, and we're going to be getting the position frequently, and that will be based on this maximum age attribute. So I've configured it for every 10 seconds. You can configure it based on your application's needs. And then I'm just checking if the location is the same as the one which is the one which is in the backend. And if it's the same, I'm setting the state for display to true. So once I do this, you can actually see that within the confetti gist I have a flag called visible. This visible flag is basically a boolean value telling whether I should display this particular element or not. So initially this display is set to false, which we initialize to the constructor. Now on reaching the particular application, the particular destination, sorry, we set display to true. And once it's set to true, the render function is invoked again with the new value. So visible is true, and then you get your confetti being shown on the screen. So the second type of scene we're going to be looking at is the marker-based scene, like we saw in the demo. So before we understand marker-based scene, we actually need to understand what markers are. So markers are some sort of visual clues the tracking engine will actually be searching for and scanning the environment. So it can be something as simple as an image, it could be shapes like rectangles, triangles, etc. Or it could be some sort of pattern. So once your tracking engine actually identifies these particular markers, your objects within the markers are actually going to be attached to it, or the right word to use is anchored. So once once you actually find out the marker for that particular the tracking engine is able to find the marker, you're going to have a method called onAnchorFound. So in that you can have some kind of processing which you would like to do. So the best part about markers is that they are trackable. So no matter how you move your device, the objects within the marker are going to be staying in the same place. Also, to find markers easily, you need to make them more distinct, and you want to keep them high contrast, because sometimes it's difficult for the tracking engine to actually identify markers accurately. So you can have 2D markers and 3D markers. 2D markers are more efficient to scan for the tracking engine, whereas 3D markers are much more difficult because it's looking at different sides of the particular object. So if you scan an object well, then you can go ahead and use 3D markers, but I would recommend you to use 2D markers when you're starting to develop your Hello World application. Also, the marker would be created using something known as a tracking target. So through this tracking target, you would basically specify an image telling the tracking agent, hey, we need to look for this particular target, and we will attach that in the target field for the image marker. So I'll show you how the code for the application looks like. So I'm just going to show you the entire application code. So this is app.js when the application is initially launched. So I'm just going to go straight to the render function. In the render function, I have a simple flag to check if the user is already logged in. So if the user is already logged in, I'm going to show him the actual augmented reality application. If he's not logged in, I'm going to return him a login comment. That's pretty straightforward. Coming to the actual augmented reality part of it, even within that, we have two different states. One is if the user has not found any clues, or if the user has found all the clues. If the user has not yet, if he's found all the clues, I'm going to return this particular part of code, which is basically saying congratulations, you found all the clues. And if the user hasn't yet found all the clues, then I'm actually going to give them some sort of augmented reality experience, and that will be using this particular piece of code. So within here, I have two parts. One is the actual augmented reality part of it, and the other is a counter just for displaying the number of clues the user has found. So within the augmented reality part of it, there are a couple of things that you need to note. Firstly, you need to specify an API key which you will get from your React when you start a trial on their website. Secondly, you just need to specify the initial scene for augmented reality application. In our case, it's just a bunch of markers, and that's the scene which I've mentioned over here. And you can attach some styles to it in case you don't want the augmented reality application to optimize.
Thank you. Yeah.